Hello, dear students. Today we are going to study the topic of 11th, that is concentration. Inside this concentration, we will specifically discuss molarity and molality. Before starting concentration, let's first let me ask you a question. Have you been prepared? Have you ever been prepared a lemonade solution? Your answer will be sure, yes. So in preparing lemonade solution, if I ask you what were the substances you have used, you will say, sir, I have used solute plus solvent. Okay. So specifically, what were the solutes? So you will say, sir, in solute we have used lemon juice and salt, and the solvent we have used as water. Okay, good. So now if I ask you how much salt you have used, so you will say, sir, I think we have used half a spoon of salt, or you will say I have used 2 gram of salt, or you will say I have used 5 gram of salt in 100 ml of water. So from here we define concentration. So concentration is actually quantifying the amount of solute you have used in some ml of solvent you have taken. So if we define solute and solvent, solute are the substance which gets dissolved in other substance. So solute is the substance which gets dissolved in other substance. So other substance is solvent, and the substance which is getting dissolved is solute. Okay. Now let's remove lemon juice from here. Let's keep salt and solvent. Solvent is water. So we have taken salt plus water we have taken. Okay. So salt is our solute and water is our solvent. Okay. Now let's try to quantify it. Let's say we have taken 100 ml of water. Now if we want to prepare a salt solution, we will take some amount of solute, let's say 5 gram of salt you have taken. So if you're quantifying that this many grams of salt we have taken in 100 ml of water, then we can say that 5 gram of salt is mixed with 100 ml of solution, 100 ml of water, and we prepared a solution whose concentration is 5 gram divided per 100 ml water. What does it mean? It means that if you are taking this solution, you would say that this many gram of solute you have dissolved in this many grams of solvent. So the concentration of this solution is this 5 divided by 100, so it's 0.05 gram per ml. What does it mean? It means that per ml of solution, if you will take, you will find that this many grams of salt is dissolved in that solution, it dissolved in that solvent. So that's the meaning of concentration. Okay, so good. So we have understood what is concentration. Now let's go ahead and let's understand what is molarity and what is molality. Okay. So molarity is a way of expressing concentration. Molarity is a way of expressing concentration, or you can say is a way of telling how much solute we have dissolved in a given amount of solvent. So molarity is expressed as, you will take the solute, so number of moles of solute, and you have taken the solute, you convert into the number of moles, and you know that how you can convert into moles. Moles you can calculate. Moles is given by, you take the mass given to you, mass in grams, and you dissolve and you divide it by molar mass in grams per mole unit. Okay. So if you have taken some x gram of solute, and you have taken some ml of solvent, so you will first convert the grams of solute into number of moles of solute. How? If you know the compound, you will know the molar mass of that compound, and you take the mass and you divide by the molar mass, and you will get the number of moles of the solute. Now the next thing you have to do, you have taken the number of moles of solute, and you will divide by volume of solution in liters. So you have to divide the number of moles of solute you have taken and divide it by the volume of the solution in liter. Good. So this will give you the molarity. This molarity is expressed as capital M. So let's say 5m is the concentration of a solution. So what does it mean? It means that 5 moles of solute you have dissolved in per liter of solution. This 5 molar, this molar is equivalent to this unit, moles per liter. This is the unit of molarity. So if 5 mole is the solution, what does it mean? 5 moles of solute has been dissolved in 1 liter of that solution. 5 moles of that solute has been taken, and the volume of the solution is 1 liter. So you have added the amount of solvent to make up the volume as 1 liter. So uh, this is the concentration of that solution we prepared by adding 5 moles of solute, and by making the solution making the volume of the solution as 1 liter. Okay, good. So now let's do a problem based on this. It's going to be a very interesting problem. So the problem says that, let's say you have taken 60 gram of glucose. 60 gram of glucose. The molecular formula of glucose is C6H12O6. So you have taken 60 gram of glucose, and you have added and you have added some amount of water to make up the volume of solution you have made by adding some amount of water. 2 liters, let's say 2 liter volume you have made. Okay, so you have taken 60 gram of glucose and you have added some amount of water to make up the volume of the solution as 2 liter. Okay, good. Then if I ask you to find the molarity of the solution, so molarity you can quickly find. Molarity is number of moles of solute. So gram is given to you, 60 gram is the mass given to you, and now you have been asked to calculate the molarity. So first what you have to do, you have to calculate the number of moles of solute, and you will divide by the volume of the solution in liter. So number of moles of solute, you have 60 gram. You have the molecular formula, you can calculate the molar mass from here. So molar mass you can easily calculate. So molar mass is 12 times 6 plus 12 from here, and 16 times 6 from here. So this is 72 plus 12 plus 96. So it's 180 grams per mole. So you know the number of um, the molar mass, it's 180 gram per mole. And now you want to calculate the molarity is number of moles of solute. So number of moles you can calculate from mass divided by the molar mass. So number of moles will be 60 divided by 180. So 60 divided by 180 divided by volume of solution in liter. So volume is 2 liter. Okay, so this will give you this much m. So this value will be 0 0 cancelled, 6 3 is 18, 3 2 times 6. So 1 by 6 m is the concentration of the solution you have prepared by taking 16 of glucose and making up the volume by adding water to 2 liter. Good. Now, if another question can be asked from here, that if I have taken 20 ml of this solution, this concentration of this solution I have taken. So concentration of the solution we found 1 by 6m. Now, if the question is there, that let's say if you have taken 20 ml out of this solution, and how much gram of glucose inside that 20 ml of solution, if that is asked to you, then how would you calculate? So let's go ahead and let's calculate this. We saw here that by adding 60 gram of glucose and making the volume to 2 liter, we saw that the concentration we found, is 1 by 6m. Now the solution which you have prepared, from that solution you have taken 20 ml out. 20 ml out. You have taken 20 ml out, and you have been asked how many grams of glucose is present inside this 20 ml of solution, of this solution which you have taken out from the solution which you have prepared by adding 60 gram of glucose to, and you have made the volume 2 liter. So I hope you have understood the question. The question is, you have taken 60 gram of glucose and you made the volume 2 liter. So you found the concentration, and the solution which you have prepared, you have taken out 20 ml of this solution from the solution which you have prepared by adding 60 gram of glucose and making the volume 2 liter. Now you have taken out 20 ml. Now you have been asked, you have taken out 20 ml out. Now you have been asked how many grams is present inside the solution. How many grams present inside this 20 ml solution? Okay, very good question. Now we have to solve this. Good. So first let's understand the concentration which we found is 1 by 6 molar. What does it mean? It means 1 by 1 mole per 6 liter, if you express like this. Okay, before this we can go like this, that the concentration is going to be constant. For let's say you have prepared this, if you are taking 2 liter solution and you have added 60 gram, so the concentration is going to be constant. The concentration is going to be the same because the solute is uniformly dissolving. So concentration is going to be the same. Now, you know the volume given to you. The volume is 20 ml. So volume is 20 ml. You know the concentration we expressed as number of moles divided by volume. So the concentration is going to be the same. The concentration is 1 by 6 molar. 6 molar, and volume you have to get convert into liter. So volume here is 20 ml. So 20 ml you will divide by 1000 liter, 1000 to convert into liter. So this is 20 by 1000. This will give you the number of moles. This will give you the number of moles. So how many moles you are getting? You are getting 0 0 cancelled, and 2 5 50, and you are getting 1 by 6 times 50, so is 3300. So 300, 1 by 300 moles of glucose you are having in this 20 ml of solution. Okay, now you need to calculate the mass. So how many grams of glucose was there in 20 ml of solution? If you want to calculate the mass will be number of moles, and you multiply with the molar mass. Okay, so number of moles you got is 1 by 30, 1 by 300 into your molar mass was 180, which we have calculated 180 grams per mole. So 100 cancelled, 6 3s are 6 5s are, so 3 by 5 grams, it means 0.6 gram was 0.6 gram of glucose are present inside that 20 ml of solution which we have taken out of this solution we have prepared. So by this is a very good question. So you have prepared a solution. From there you have taken out some amount of solution, and now you have been asked how many grams of solute was there. So by doing this calculation, we found that 0.6 gram of glucose is present inside this 20 ml solution which you have taken out of the solution which you have prepared. Okay, so this is all about molarity. Now we should discuss molality. Okay, so molality is also a way of expressing concentration. So you would learn now how would we express molality. So look, we have seen molarity, how we would express molarity. Now we should look how we express molality. See, molality is expressed as, you would take the number of moles of solute as you have taken in the case of molarity. You take the same way, you calculate the number of moles of solute. So you calculate number of moles of solute, and you divide by mass of solvent in kg. Okay, so you will take the number of moles of solute, will divide by the mass of solvent in kg, and this is expressed as a small m. Small m means molal. So this is expressed as a small m, molal. Okay, so let's do a very simple problem based on this. Let's say you have taken 60 gram of glucose and 200 ml of water you have taken. 200 ml of water you have taken. Now it has been asked you how much is the concentration in terms of molality, in molar terms. Okay, so once again, glucose, the molecular formula is C6H12O6, C6H12O6. Okay, the molar mass will be 180 grams per mole. This will be the molar mass. Okay, so from here we can calculate the number of moles of solute. So number of moles will be 60 divided by 180, so it's going to be 1 by 3 moles. Okay, now let's say you have taken 2 liter 2 liter of water you have taken. 2 liter of water as a solvent you have taken. Okay, so 2 liter water means the density of water we know it's 1 gram per ml. So for 2 liter, the density of water is 1 grams per ml. So you know that for 2 liter of water, the volume is 2 liter. So you have taken 2 liter water. So it means your mass of water is 2 kg from here. So we can express into kg terms. So it will be 2 kg. So you can say its value is 1 by 6 molal. 1 by 6 molar. So this is how you would express molality, and we have seen how would express molarity. So quickly summarize, we have seen molarity. Molarity you can express as you take the number of moles of solute and you divide by the volume of solution in liter. And for expressing molality, you take the number of moles of solute and you divide by the mass of solvent in kg. So this is how you can express molarity and molality, and some questions we have done. So I hope you have understood this. So that's all for today. Thank you.